Our market share in polyester filaments up 20% in 9 months. Tremendous benefit, well over $1 million a year benefit to us. I mean, if I add up what the last year of continuous improvement has delivered to us, it's in the range of $5 to $6 million a year.
We were throwing away over 6 million pounds of yarn a year. 1% improvement in eliminating the waste would mean to us $40,000. We've made over $1.5 million in savings.
Prior to the MVT, we had about an 8.46 average defect rate. During the MVT, we had a 6.42. And afterwards, we're now at a 4.64. We wanted a 30% reduction in pack fallout, when in reality, we had 45%.
Yarn breaks are a main contributor of our cost. And when you look at it, we have 29,000 breaks per week. We spend a little shy of $3 million a year in that cost. Our goal when we started this project, we wanted a 30% reduction in DTY breaks. We've got a 40% improvement. We've saved $1.1 million so far already.
We're on a constant quest to provide the most technologically advanced, aesthetically pleasing automotive interior cloth, of course at the lowest cost with the shortest amount of lead times. We had an issue in knitting to where we only had 50% of the fabric was good for bolster. So what did MVT do for us? It let us test many ideas simultaneously. It resolved complex process by individual factors. It allowed us to concentrate our efforts on auditing and adjusting quality critical parameters. 64% of everything that we were auditing, we don't have to audit anymore because it doesn't affect the quality of the fabric. So we increased our throughput first quality from 50% to 98%.
To give you an idea of what a break is worth to the customer, every time it breaks, it costs them about $1, so it could add up pretty quick. The status quo condition, we predict about 6 breaks. Clean heaters gives us fewer breaks, and we predict 2 breaks, which predicts a 66% improvement in customer texturing breaks by simply cleaning the heaters under this new method.
When we do the test that we've seen from the MVT, we're saving 15 minutes per cycle, which really translates to a lot more utility savings. Through fiscal year 13, through the summer months, we've seen a 38% increase from year over year on product margin due to these utility savings.
Royal Industries today has grown for the last 6 years somewhere around 37–38% annually. Our profits have gone up 100% since we've started this program. How have we done it? A lot of hard work, but we have set out with a commitment to make the program work because we know long range, if we're going to compete in the world market, we've got to do things better and we've got to be more efficient and we've got to produce a quality product.
So what's the impact of my business? Overall, that's a 36% improvement in draw machine runtime. 33 million pound capacity increase by doing nothing more than increasing runtime by 68 minutes a shift. And the only way we knew how to get the pounds that we needed to meet the demands of that market was to put in a new machine. We got 35.7 million pounds, do not need to spend that $15 million on that new machine.
If we had have taken the stance of doing the old one factor at a time method, it would have taken us over 8 million combinations to be able to achieve what we did through this MVT. We're able to drive our costs down somewhat because our waste percentages are going to go down. Our first pass yields are going to go up. 28% increase in throughput we actually made through this entire process.
And so what MVT did for us, obviously we got to test a number of ideas simultaneously. We didn't have to invest in any capital. We didn't have to go build a new machine. We didn't have to add anything to our current machine. This let us identify what the right knobs in conjunction together were to turn up that bond strength coming off the machine. So 751% improvement in creating a foam tear condition. So we went from our bond strength being questionable, obviously. Now it's so good that we can't measure it and we can't communicate to them using the same method how good we are.
Once we started utilizing the MVT process and methodology and statistics, we were able to apply a mathematical equation in our plant monitor, which is a system that governs or monitors how each machine is running. It looks at breaks, thread time or run time, and C-quality events and other types of breaks. 50% of every break that occurs in our plant happens before that package has reached a full run time. So half the time we're making product that doesn't reach full size. If it's run 5 hours, then in most cases that size package is packable and it can be sold. If it's less than that size, it goes to waste. So after MVT overhaul, positions are averaging around 13.7 hours.
At our fabrics plant, where we make the primary backend and the secondary backend for our carpet, we have been able to continuously reduce the variation and therefore continues to improve our output and the quality of our product. In our rug weaving plant, we were running, as you can see, at 53% of total available time. There is a lot of downtime factored into the process. You have to change beams, you have to change colors on the creel rack. That takes a tremendous amount of time. But we were still able to bring that up to 74%, which is truly the difference between a mediocre performance to an almost impossible performance.